Did you know that on Neptune, supersonic winds whip around at over 1,300 miles per hour? These winds are so powerful that they could easily sweep across entire continents if they were on Earth. The sheer force and speed of these winds are mind-boggling, making Neptune a planet of extremes. These winds are the fastest we've ever recorded in the solar system. They are driven by the planet's internal heat, which is still a mystery to scientists. Despite being so far from the Sun, Neptune radiates more heat than it receives, fueling these incredible wind speeds. This incredible fact hints at the powerful and mysterious nature of the ice giants Uranus and Neptune. These planets are not just cold and distant, they are dynamic and full of surprises. Their atmospheres are composed mainly of hydrogen, helium, and methane, giving them their characteristic blue and green hues. These planets are far from being giant balls of ice. Beneath their thick atmospheres, they have layers of water, ammonia, and methane ices, but their cores are rocky and metallic. This unique composition sets them apart from the gas giants Jupiter and Saturn. They are dynamic worlds with swirling storms, faint rings, and intriguing moons. Neptune's Great Dark Spot is a massive storm system similar to Jupiter's Great Red Spot, while Uranus has a complex ring system and numerous moons that are still being studied. Uranus and Neptune, the seventh and eighth planets from the Sun, represent a fascinating class of planets. Their distance from the Sun means they receive very little solar energy, yet they exhibit some of the most extreme weather patterns in the solar system. We call them ice giants. This term reflects their unique composition and the presence of ices in their makeup. Unlike the gas giants, their atmospheres are not dominated by hydrogen and helium alone, but include significant amounts of water, ammonia, and methane. Their compositions differ greatly from the gas giants Jupiter and Saturn. While gas giants are mostly hydrogen and helium, ice giants have a larger proportion of heavier elements. This difference in composition affects their formation, structure, and the way they interact with their environments. These differences hold clues to the formation and evolution of our solar system. By studying Uranus and Neptune, scientists hope to understand more about the processes that shaped our planetary neighborhood. These ice giants may even offer insights into the formation of exoplanets in other star systems, making them key to unlocking the mysteries of the universe. Unlike the gas giants, which are primarily composed of hydrogen and helium, Uranus and Neptune contain a higher proportion of heavier elements. These elements include water, methane, and ammonia. These compounds exist in ice form in the planet's frigid depths. This unique composition is why we call them ice giants. Studying these ice giants gives us a broader perspective on planetary systems. It helps us understand the diversity of planets that can exist in the universe. Their formation and characteristics can provide insights into the conditions of the early solar system. This knowledge can even help us understand planetary formation in other star systems. Despite their importance, Uranus and Neptune remain the least explored planets in our solar system. Only one spacecraft, Voyager 2, has flown by each of these distant worlds. The data sent back from Voyager 2 in the 1980s provided our first close-up glimpses of these planets. The immense distance of Uranus and Neptune from Earth poses a significant challenge. It makes missions technically difficult and expensive. This challenge contributes to the limited exploration of these icy giants. However, the scientific community recognizes the importance of studying these planets. Uranus and Neptune possess unique characteristics that set them apart from the other planets in our solar system. These two ice giants, located in the outer reaches of our cosmic neighborhood, are shrouded in mystery and intrigue. Their atmospheres, rings, and moons offer a fascinating glimpse into the complexities of planetary science. Uranus, with its dramatically tilted axis, appears to rotate on its side. This unusual orientation is believed to be the result of a colossal collision with an Earth-sized object long ago. The tilt gives Uranus a unique rotational pattern that is unlike any other planet in our solar system. This extreme tilt results in seasons that are unlike anything we experience on Earth. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. These prolonged seasons create a dynamic and ever-changing environment on the planet's surface. Neptune, on the other hand, is known for its incredibly strong winds, which are the fastest in the solar system, reaching speeds of up to 1,200 miles per hour. These powerful winds drive the planet's weather systems and contribute to its dynamic and turbulent atmosphere. These winds create massive storms, such as the Great Dark Spot, which was observed by the Voyager 2 spacecraft during its flyby in 1989. This storm, similar in size to Earth, showcased the raw power and intensity of Neptune's atmospheric conditions. Both Uranus and Neptune have ring systems, although they are much fainter and less prominent than the majestic rings of Saturn. These rings are composed of dark, narrow bands of dust and small particles that encircle the planets. The rings of Uranus and Neptune are made up of tiny particles ranging from micrometers to meters in size. These particles are thought to be remnants of ancient collisions and the gradual disintegration of moons and comets over billions of years. Scientists believe that these particles are remnants of comets, asteroids, or shattered moons. The constant bombardment of these celestial bodies has contributed to the formation and maintenance of the rings over time. In addition to their rings, Uranus and Neptune also have numerous moons. Uranus has 27 known moons, while Neptune has 14. These moons vary greatly in size, composition, and geological activity, making them intriguing subjects of study. The moons of Uranus and Neptune exhibit a variety of geological activities and compositions. Some moons have icy surfaces with signs of tectonic activity, while others show evidence of past volcanic activity. These diverse characteristics provide valuable insights into the history and evolution of the outer solar system. Some of these moons even show signs of potential subsurface oceans, which could harbor the conditions necessary for life. The presence of liquid water beneath the icy crusts of these moons makes them prime targets for future exploration and study. Section 5. Could there be life? One of the most intriguing aspects of Uranus and Neptune is the possibility of subsurface oceans. Scientists believe that beneath their thick atmospheres lie vast oceans of water, ammonia, and methane. These oceans could potentially harbor conditions suitable for life. While life on the surface of these planets seems unlikely due to extreme temperatures and pressures, the potential for life in these subsurface oceans is an exciting area of research. It expands our understanding of the habitable zones around stars and the potential for life beyond Earth. Section 6. Magnetic anomalies. A tale of two tilted fields. Both Uranus and Neptune possess unusual magnetic fields. These fields are not only unique but also quite complex, making them a subject of great interest for scientists and astronomers alike. Unlike the magnetic fields of other planets in our solar system, the magnetic fields of Uranus and Neptune are characterized by their significant tilt and offset from the planetary centers. Unlike Earth's magnetic field, which is aligned relatively close to its axis of rotation, the magnetic fields of Uranus and Neptune are dramatically different. Earth's magnetic field is generated by the movement of molten iron within its outer core, creating a relatively stable and predictable magnetic environment. In contrast, the magnetic fields of these ice giants are significantly tilted and offset from their centers. This misalignment suggests that the internal processes generating these fields are quite different from those on Earth. The magnetic poles of Uranus and Neptune are not located near their geographic poles, leading to a complex and dynamic magnetic environment. The reasons for these unusual magnetic fields are still not fully understood. Scientists have proposed several theories to explain these anomalies, but definitive answers remain elusive. The study of these magnetic fields is crucial for understanding the internal structures and dynamics of Uranus and Neptune. Scientists believe that the magnetic fields might be generated by the movement of electrically conductive fluids deep within the planets. These fluids could be in the form of a supersonic water ammonia ocean or other exotic states of matter that exist under the extreme pressures and temperatures found within these ice giants. These fluids could be composed of water, which under high pressure and temperature conditions behaves very differently than it does on Earth. In addition to water, ammonia and methane are also believed to play a crucial role in the generation of these magnetic fields. These substances, when subjected to the extreme conditions within Uranus and Neptune, can become electrically conductive and contribute to the magnetic field generation process. Further study of these magnetic fields could provide valuable insights into the internal structures and dynamics of these ice giants. By understanding the magnetic fields, scientists can infer details about the composition, temperature, and pressure conditions within Uranus and Neptune. This knowledge not only helps us understand these distant worlds better, but also contributes to our broader understanding of planetary science and the formation of magnetic fields in general. Section 7. Reflecting on the ice giants, a universe of discoveries. Uranus and Neptune, the ice giants of our solar system, hold many mysteries. They are worlds of extreme weather, faint rings, and potentially life-harboring moons. Their unique compositions and characteristics offer valuable clues about the formation and evolution of planetary systems. While they remain the least explored planets in our solar system, their scientific importance is undeniable. Future missions to these icy giants will undoubtedly unveil more secrets and enhance our understanding of the cosmos. Section 8. What secrets do they hold? Join the exploration. What fascinates you most about Uranus and Neptune? Is it their extreme weather, their mysterious rings, or the possibility of life in their hidden oceans? As we continue to explore these distant worlds, we are sure to uncover even more wonders that will spark our imaginations.